How Docker works. Understanding the complete architecture. Introduction. Docker has revolutionized how we develop, deploy, and manage applications by introducing containerization technology. This comprehensive guide walks through Docker's three-tier architecture and explains how each component works together to create a seamless containerization experience. The three-tier Docker architecture. Docker operates on a client-server architecture with three main components. Docker Client, the user interface for Docker commands. Docker Host, the runtime environment where containers live. Docker Registry, the storage and distribution hub for container images. Let's explore each layer and understand how they interact to make containerization possible. Layer 1. Docker Client, your gateway to containerization. The Docker Client is your primary interface for interacting with Docker. It's where you execute commands that orchestrate the entire containerization process. The three essential commands. 1. Docker build, green arrow. The Docker build command is where containerization begins. This command reads instructions from a Docker file, creates a new container image layer by layer, sends the build context to the Docker daemon, produces a ready-to-use container image. Example workflow. Docker build -t myapp-latest. This command tells Docker to build an image tagged as myapp-latest using the Docker file in the current directory. 2. Docker pull, red arrow. The Docker pull command downloads pre-built images from registries, connects to Docker Registry, like Docker Hub, downloads the specified image and all its layers, stores the image locally for immediate use, enables you to use images created by others. Example workflow. Docker pull Ubuntu-20-04. This downloads the Ubuntu 20-04 image from Docker Hub to your local machine. 3. Docker run, purple arrow. The Docker run command brings images to life by creating and starting containers, takes an existing image as input, creates a new container instance, starts the container with specified configurations, runs the application inside the isolated environment. Example workflow. Docker run -d-p 80:80 nginx. This creates and starts a container from the nginx image, running it in detached mode and mapping port 8080 to container port. Layer 2. Docker host, the runtime powerhouse. The Docker host is the heart of the containerization system, consisting of two critical components, the Docker daemon and the storage systems. Docker daemon, the master orchestrator. The Docker daemon, also called Dockered, is the persistent background service that manages everything Docker related. Core responsibilities. API server. Listens for Docker API requests from clients. Image management. Builds, stores, and manages container images. Container lifecycle. Creates, starts, stops, and destroys containers. Network management. Handles container networking and communication. Volume management. Manages persistent data storage for containers. How it works. When you execute a Docker command, the client sends a REST API request to the daemon. The daemon processes this request and performs the necessary operations, whether that's building an image, pulling from a registry, or running a container. Container storage. Living applications. The container section shows multiple running container instances, represented by the blue container icons. Each container runs as an isolated process on the host system, has its own file system, network interface, and process space, shares the host's kernel, but remains completely isolated from other containers, can be started, stopped, paused, and destroyed independently. Container characteristics. Lightweight. Containers share the host OS kernel, making them much smaller than virtual machines. Portable. Containers run consistently across different environments. Scalable. You can easily spin up multiple instances of the same application. Isolated. Each container operates in its own namespace, ensuring security and stability. Image storage. The blueprint library. The images section contains your library of container templates. In the diagram, we see Ubuntu image, a base operating system image, other custom application images, built from Docker files containing your application code. Image characteristics. Layered architecture. Images are built in layers, allowing for efficient storage and transfer. Read-only. Images are immutable templates used to create containers. Reusable. One image can spawn multiple containers. Versioned. Images can be tagged with different versions for better management. Layer 3. Docker Registry, the central distribution network. The Docker registry serves as the central hub for storing and distributing container images. The most popular public registry is Docker Hub, but organizations often maintain private registries. Registry components shown. 1. Ubuntu image. The Ubuntu logo represents one of the most popular base images available, provides a minimal Ubuntu operating system, serves as a foundation for building custom applications, regularly updated with security patches and improvements. 2. Docker Hub. Represented by the Docker whale logo, Docker Hub is the default public registry for Docker images, home to millions of container images, offers both free and paid tiers for image storage, provides automated builds and webhooks. 3. Nginx. The Nginx logo shows another popular image, a high-performance web server and reverse proxy, commonly used for serving static content and load balancing, available in multiple variants and versions. 4. Custom images. The red container stack represents custom application images, built by developers for specific applications, can be pushed to registries for team sharing, often built on top of base images like Ubuntu or Alpine. The complete Docker workflow. Understanding the color-coded flow. The diagram uses a color-coded system to show how these components interact. Green flow, build process. Developer writes a Docker file, executes Docker build command. The Docker daemon reads the Docker file, creates a new image layer by layer, stores the completed image locally. Red flow, pull process. User executes Docker pull command. The Docker daemon connects to the specified registry, downloads the requested image and all its layers, stores the image locally for future use. Purple flow, run process. User executes Docker run command. The Docker daemon locates the specified image, creates a new container from the image, starts the container with the specified configuration, application runs inside the isolated environment. Advanced Docker concepts. Image layering and efficiency. Docker images use a layered file system approach. Each instruction in a Docker file creates a new layer. Layers are cached and reused across different images. Only changed layers need to be rebuilt or downloaded. This makes Docker images highly efficient in terms of storage and transfer. Container orchestration. While this diagram shows individual containers, Docker can work with orchestration tools. Docker Compose for multi-container applications, Docker Swarm for container clustering, Kubernetes for enterprise-scale container orchestration. Registry security and privacy. Organizations can maintain private registries for proprietary application images, enhanced security and compliance, better control over image distribution, integration with existing authentication systems. Best practices in real-world applications. Development workflow. Development. Use Docker build to create images during development. Testing. Use Docker run to test applications in isolated environments. Distribution. Use Docker push to share images with team members. Deployment. Use Docker pull and Docker run in production environments. Production considerations. Multi-stage builds. Optimize image size by using multi-stage Docker files. Security scanning. Regularly scan images for vulnerabilities. Resource limits. Set appropriate CPU and memory limits for containers. Monitoring. Implement logging and monitoring for container health. Conclusion. Docker's three-tier architecture provides a robust foundation for modern application deployment. The Docker client offers intuitive command line interfaces, the Docker host provides reliable runtime environments, and the Docker registry enables seamless image distribution. Understanding this architecture is crucial for leveraging Docker's full potential in your development and deployment workflows. Whether you're building microservices, modernizing legacy applications, or implementing DevOps practices, Docker's containerization technology provides the consistency, portability, and efficiency needed for modern software development. The beauty of Docker lies in its simplicity. Build once, run anywhere. This principle, enabled by the seamless interaction between these three architectural layers, has made Docker an indispensable tool in the modern software development toolkit.